Okay, so 5.1, here's my take on a couple of quick things. If we first have to figure out, let's see here, what did I do that for? Oh yeah, f of x is 9x plus 5, and then g of x is 5 minus x squared. We got to calculate the following, and so f composed g, or f of g of 0, that means we're going to start by, here let me clean that up a little bit. We'll start by shooting in 0 into the g function first. That's our inner function. 0 goes into the g function first. And then once we get an answer to g of 0, then we'll do f of that answer. So let's first figure out g of 0. So if we have f of g of 0, we will first figure out what the heck is g of 0, and then we'll figure out f of that answer. And so g of 0, let's see how that goes. G of 0 is me plugging in 0 into this g function. And so let's see, if I put a 0 in there, this would be 5 minus 0 squared. And so we could certainly write that. That would be 5 minus 0 squared. Hey, something just happened. 5 minus 0 squared. And 0 squared is 0, so it's just 5 minus nothing is 5. And so if we were to say, well, what happens when you plug in 0 into a g function? In this case, it gives you, what is it? 5. I was about to put 0. Don't tell anybody. Anyway, it gives us 5 here. Let's clean that up. It gives you 5. So then g of 0 becomes 5. And now we have to figure out f of that value. So the answer, f of 5, we'll shoot that 5 into the f function now. F of 5 is us looking back at the f function. 9x take away 5, and it'll be 9 times 5 now. Plus 5. And then we'll just see where it goes from there. 9 times 5 is 45, plus 5 is like 50, I guess. That's what I'm looking for this one. Same kind of thing as you go throughout, all of this stuff, is we're just saying we plug into the inner function first. In this case, it would be f of 0, and then we'll figure out that answer, and then we'll do g of the answer. Hey, g of the answer. And then, let's see here, next thing up, same thing on this one. We have, if they say f composed g of negative 4, remember, this is the same notation, it's the same idea with different notation. They're saying, essentially, f composed g is like f of g of 4. But that's like us just saying, let's plug negative 4 into the g function, and then that answer from g of negative 4, the answer of that will go into the f function. And so same idea with those. You'll just have, it'll be just negative 4 goes into g, so you plug a negative 4 in there. That would be negative 4 plus 7 is like 3 or something. That would be a 3, I think. And then you would take that answer, which I believe is 3, and then shoot the answer into the f function. And so then you put 3 into the f part, and it would be like 3 squared plus 7 times 3. In my head, that's like, 9 plus 21. So like 9 plus 21 is like 30, I guess. Anyway, I didn't write any of that down. I feel like I just wanted to talk about the idea with those ones. Anyway, next one though, now we're composing functions together as they are. And so on number 3, we have f of g of x. They're not asking for a particular value. They're saying take g of x and shoot it into the function f. And so that means we'll take g of x, this g function, which is 6x, or 6 over x plus 7, and we'll shoot that, this whole mess, into the f function, which means every time I see an x, I'm going to write this whole g function instead. And so let's clean that up a little bit. Here we go. So at its heart, if you're wondering about like a good approach for these ones, notice that it starts, the very heart of it is that it is an f function. So it'll look like an f function. If we plug anything into it, it'll still be 1 over something minus 7, because that's what f function does. It's 1 over something minus 7. So we'll start that way. Since it's f of something, we'll say this is 1 over something minus 7. Even if we don't know what the something is, that's what an f function does. And since it's f of g of x, that just means the g of x function is what the something is. And so we'll put the something there. That's 6 over x plus 7 gets shot into it. That's our g function sitting there inside of the f function now. And then we just clean it up best that we can. plus 7 and minus 7 look like they're canceling out. And then we have 1 on top over 6 over x, which is almost cleaned up. You could certainly treat this like a times reciprocal thing if we were to picture this as being like 1 that's equal to 1 divided by 6 over x. Some kind of divide that is. Divide by whatever, 6 over x, which is the same thing as 1 times by x on top over 6. And of course, you probably don't need to times anything by 1 because it doesn't do anything. So I'm looking at x over 6 when I look at that one. That's the idea with those. If it's an f function, make sure it looks like an f function. And then we're plugging a g into that f. And then the next one, you'd be like, if it's a g function, it'll look like a g function with the f function inside of it. Similar ideas behind this stuff in number 4 here. We're just, remember, f composed g of x, if we're looking at number 4, f composed g of x is the same idea. This is a different notation for the same kind of idea. This is an f, just so you know. When you see f composed g, it's okay to think of it as f of g of x. It's a g of x that's been placed inside of the f function. It's the same thing as we did above. It's just these are nicer functions because there's no fractions in them. Anyway, that's the idea there. That's my take on that stuff. And then here we get a little bit weird. So on number 6, I'm seeing f of x is this function. It's radical 2 take away x, and g of x is this whole other thing. And we're supposed to now not just compose them, but we have to figure out the domain of the composition of them. So first maybe we'll compose the functions. Let's look at f composed g and figure out the domain of that. So f composed g, that would be f of g of x. And so we'll plug the g into the f function. If it starts out as an f, it'll look like an f. So f function is this mess. Will be like square root of 2 take away something. That's what f function does. And then the something is the g function, and that'll be the x squared take away x. That's a weird function for sure. So f composed g is square root of 2 take away of x squared minus x. And then we can maybe clean that up a little bit, and then we'll try and figure out the domain. If I were to clean that up, let's see, that would be square root of, if I distributed the negative in, it would be like a minus distributing into both of these kind of thing. Then it would be the x squared would be negative, so negative x squared. And then negative of negative x would be a plus x, and then we have a positive 2 there. That's one take on it anyway. So that would be one good take on that. And then from there, guys, I guess to finally, this would be a cleaned up enough version, I guess, of the domain or of the function. That would be fine. But they're asking us not what is the function, what was the composite function, but what is the domain of f composed g. And so if we have f composed g over here on the right, we're looking for the domain of it. Now we just got to remember a domain is the set of all the x's that I can get away with plugging in. And there's no fractions in this story. So there's no reason that I couldn't plug in anything I want to offhand. That nothing's going to go undefined. But there is an issue with square roots. Because square roots in the real number system, they don't do negatives because we can't square root negatives in the real numbers. So we're just going to make sure that we get that. We'll make sure that this junk don't go negative, So we could solve it this way, and we could be like, well, negative x squared plus x plus 2, everything that's inside that square root, I want to make sure that it doesn't go negative, Maybe we could say something like, I want it to be at least 0. Greater than 0, even equal to 0 is fine, because we can do a square root of 0. But I don't want it to be negative. And so then from there, wham, 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 we'll just solve this out. You can do this by factoring or by the quadratic formula. I don't like having a negative on my x squared. That bothers me. It's harder to figure stuff out that way. So if you don't mind, I'm going to times both sides by a negative, and that'll be, we'll put like a times a negative there. Both sides of the equation, that'll be a regular x squared minus x minus 2, and then 0 is still 0. But just remember, if you times by a negative, that's when inequality flips. So do watch out for that. And then from there, we could solve this thing by factoring. And let's see here, if we factor that out, we're wondering what goes into negative 2 adds up to minus 1. I'm looking at probably, let's see here, negative 2 plus 1 should do it. So we're looking at if we wanted this thing to equal 0, really it's hard to deal with the less than or equal to. Or you could really, wisely, we should have probably just treated this as an equal sign the whole time. But whatever. So for right now, if I wanted x minus 2 to equal 0, then positive 2, it will work. Positive 2. And then something plus 1 equals 0. You guys know how that goes. That would be negative 1. So x equals 2 or negative 1. These are two values that will make this thing actually equal to 0. And we're wondering, well, what kind of values do I use to make this thing bigger than 0, So equal to is fine. I can keep them equal to 0. But I don't want it to go less than. So what we could suggest, guys, is maybe just doing the old-fashioned technique of testing junk out. So maybe we'll just save ourselves a little space over in the corner here. If we look at a number line, we'll be like, well, here's negative 1, and then over here is positive 2. And we're wondering about, like, okay, I know if I plug into negative 1, I get a 0, and it's okay to be equal to 0. So I can shade that in. I know if I go to positive 2, I can plug it in to get a 0, and that'll work out fine as well. But I don't know what happens in numbers between negative 1 and 2, so I could try, that's what that's supposed to say, just pretend it says try. So I could try something between the two of them. I would see maybe like a positive 1 or a 0 or something. I'm going to put a 1 here, and then I'll try a number on the other side over here. On the other side of 2 would be like a 3. Then on the other side of negative 1 here would be like maybe a negative 2. And we're going to try all those into our original expression, into our negative x squared plus x plus 2. We'll try all these numbers, and then that'll tell us what parts of this number line. Is it this part on the left, or this part on the right, or this part in the middle? What parts of this number line are actually good to keep us at greater than or equal to 0 as we're shooting for? So let's see if we try plugging junk in. I'm going to have to section this off here. Let's check this out. You know what? I got extra slides here. We'll just skip down to a few slides here. We were trying. Okay. So we're looking at negative 1 and 2. Those are both fine. Positive 2. And then we were going to try a positive 1. We were going to try a 3. We were going to try a negative 2. And see what this number line ends up looking like, knowing that the equal 2's are fine. So if we plug those things into our expression, negative x squared plus x plus 2, we'll see what happens. And so keeping this in mind, let's see what happens on the negative 2 side of things. If I plug in a negative 2, that's a minus of negative 2 squared plus negative 2 plus 2. If I plug that in, let's see here, this negative 2 plus 2 cancels out to nothing. And then negative 2 to the second is like 4. Yeah, so that's positive 4 when I square it. But then there's this extra negative sitting there. So negative 4 plus 0. We're looking at this as negative 4. So if I plug in this negative 2, I actually get a negative number out of it. So that does not do what I wanted. Because remember, we're hoping that this expression is supposed to end up greater than or equal to 0. We know where it's equal to 0. I'm wondering where I am greater than 0, but this is negative. When I plug in a negative 2, it came out negative, so that's not greater than 0. It's less than 0, so we'll say this. That part of the number line ain't going to work. So let's try numbers that are between negative 1 and positive 2. Well, what if we tried positive 1 here? Into the expression, that'll be here, we'll close that up. Into the expression, that'll be a negative of 1 squared plus 1 plus 2. And it's looking like this one might work out, because 1 squared is 1, then tag the negative on. Plus 1 and plus 2 is like plus 3, so this ends up being a positive number. Negative 1 plus 3 is positive 2. That does come out positive because I plugged it in, and this is a greater than 0 number. This is good. That's what I'm looking for. So numbers in between here and here, negative 1 to positive 2, numbers between those two do seem to be doing what we want. And then you can always try this other part over here. If we tried a number over here, I'm betting that it won't. You can try that and verify for sure. But it looks like our domain then is every number from -1 all the way to +2. Hey, all the way to +2, inclusive of both sides because the equal to's work here. And so that I'm thinking is our best bet on the domain from -1 all the way to +2, and we'll box them. That's what I'm getting on those. Boom, 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 boom. Where do we leave off? Yeah, so from -1 to +2, and that's what they're looking for. They say, here, let me clean this up for a second. They say for, find the domain with all A and B thing from A to B, and we know what the A is from -1 to +2, inclusive on both ends, just like they said. That's cool. On this next one, we're trying to read these little charts or graphs and understand the composition of functions here. So we have f of g of 1, and we're supposed to interpret that based on what they drew for us all up here. So let's see how that goes. Maybe we'll once again start in the inside. G of 1 we could figure out. So when they say figure out g of 1 first, and then we'll figure out f of that answer, let's start with the inside with g of 1. And this is going to be a little bit foreign to a lot of you, but notice how we have this graph says f of x and this says g of x. So we have these two different graphs. And so when we're trying to figure out g of 1, we'll look at the g graph. And when we're trying to figure out f of anything, we'll look at the f graph, and that'll be the idea. So if I saw this stuff, what I would do is I'd look up g of 1, which means I'd go over to the 1 on the g line and see how high up is that function at that point. Like if I had g of 4, and I'd look up and I'd see the 4 mark actually puts me up to as high as +3. Or g of 5 would be up as high as, it looks like 4 or something. Or maybe it's higher. I guess I drew over it, so I think it's up there. Anyway, that's what's going on with these. And so let's go ahead and look at how high up is the g function at the 1 mark. And so at the 1 mark, we're way down here. It looks like it's actually a 0 because it's 0 steps high there. So g of 1 is actually 0, it looks like. So we're going to say g of 1 ended up being 0. And so I'll do now f of that 0. And so g of 1 is 0. F of 0 we'll figure out, but that means I'll go over to the f graph, and I'll look at the x value of 0 and see how high up it is. X value of 0 is right here. It doesn't go over any, and we'll just trace it up until we run into the curve on the graph. Which in this case, I think I messed it up, but it looks like it's about 4 steps up, boom, when we hit that line. So that's looking good. Here, let's clean that up a little bit. Anyway, here's the function, and at the 0 mark, it looks like it's up 4 steps. So we'll say equals 4. And then a similar process on all of them. So let's see here. We'll do one more. If I had f of 0 first to look up, let's see here, we'll increase the old erase line. If I had f of 0 to look up first, we'd say, okay, let's start at f of 0. Here's the 0 line, and it's way up there, and that's a 4. That's how high up it is at 0, is at 4 steps up. So then we'll figure out g of that answer, which is g of 4, and then we'll look up g of 4. And so g of 4 is, here's 1, 2, 3, 4. There's the 4 spot, and we'll look up to see how high it is. And then at that 4 spot, the g function is at 3 steps high, it looks like. So we'll just go g of 4 equals 3, and that's what g compose f of 0 is, because f of 0 was 4, and g of that became 3. That's what we're looking for. All right. Okay, number 12. Oh, what did I just do? Number 12. A very similar idea. We're just looking up inputs of these composition of functions. Yeah, but this time we're using a chart, that's all. And so we'll just remember, here's the x rows, the inputs, and then this would be the output for the function f, and this would be outputs for function g. So the way this would read is if somebody said f of 3, what you would say is, well, I know what f of 3 is. Here's 3. And then if I run 3 through the f function, I get 8. So you'd say f of 3 is 8. Or if somebody said, what is g of 2? Then you would say, well, here's the number 2, because it's always here. because it's always the x values are your input values in this particular chart. And so the x's are your input values, and then we'll run it through the g function, and we'll see where it leads. And then, oh, that's interesting, 2 actually maps to 2. And so you just say g of 2 is 2. And that's what we're looking at here. Okay, let's see if we can undo all that mess. Okay. So we have to figure out f composed g of 3, or f of g of 3. I'd recommend we look up g of 3 first, and then we'll find out f of that would be the idea. So g of 3 would be, let's look up 3 in the g function. In the g function, that maps us over to a 1, it looks like. So g of 3 is 1, so then we'll say g of 3. We'll just replace that as a 1. G of 3 is 1. And then we're figuring out f of that, so now let's do f of that answer. So f of that answer is f of 1 now. So then it's like back to the drawing board, forget everything that just happened. Now we're saying f of 1, I'm going to look up 1 under the f function column, and that leads me to the number 2. And so we say f of 1 equals 2. So in the end, we could even summarize it from the beginning here. F of g of 3 equals just 2. And so that's how that mess goes. And then similar for the rest, that's what I would do there. And then number 14, yes, another domain thing. They're going to have us doing some things with these functions, dividing them, composing them. And we got to once again state the domain. And so issues that I'm noticing, anything that has an h of x in it, which is all of these things down here, anything that has an h of x in it has some issues to it, because first off, remember, square roots, we don't want them going negative. A square root of a negative number, that's bad. So we got to keep square roots to be at least at 0 or above. We got to keep them non-negative. Square root of a negative, bad. Also, with the g or with the h function, it has a whole other issue, because if you have a number over a number, you don't want it to be, it's a fraction. You don't want it to be over 0. So that's bad as well. So this is being a fraction as well. Not only does it have the square root, but it has a fraction in it. So for that reason, h all by itself, even without putting g into it, we would say the domain is a little bit restricted here, because I can't have it be 0 on the bottom, and I cannot have the square root part be a negative. And so that already filters a lot of stuff out. And then as we play around with these g's and x's together, we'll see how these issues start rearing their heads more and more. So let's look at that real quick. Here, let's giant eraser now. Here we go. Giant eraser. It's not even that big an eraser. Okay. We'll try this junk on a couple of these things. And so if we had h of x over g of x, that's the h function on top of the g function, that would look like h of x is 1 over radical x on top of g function, which is x squared minus 4. That's what h over g looks like. And then if I were to state the domain of that, we just got issues, because now we know that, first off, I don't want the square root to go negative. So right off the bat, I'm seeing a square root here. And so the x is inside the square root. What we would say is, I don't want that x. He can't go negative. So right off the bat, x, hey, now, x can't go negative. So we'd say x already needs to be at least 0, 0 or above. So that's a condition for our domain. Also, we know that I don't want this thing to be 0, because then the h part is undefined. So if I plug in a 0 for x, then we'd have the square root of 0 at the bottom, and the square root of 0, the bottom would be 0. So now over here, when we're talking domain, it's not enough to say that the x has to be greater than or equal to 0, because now the equal to part won't work. So far we have the condition that x must be greater than 0. That's looking like our domain so far. And then there's even more conditions, because now that this is a fraction, we have this function, we have this function on top of the other function. Now there's an undefined issue even right now with the g part, because this g function is the bottom of a fraction now. So we can go undefined that way too. So we're like, so far I know x, I need it to be greater than 0. Let's see what else we can find from this thing. I also need the x squared minus 4 part. to not be 0. Because if that part is 0, then we're undefined again. And so let's solve this thing out and see what makes it 0, and then we'll have some more things to throw out of the domain. If I do it by factoring, or you could do it by square roots or something, if we do it by factoring, then we get x plus 2 and minus 2, and then that means negative 2 plus 2 makes 0, and positive 2 minus 2 makes 0. These are the two values that makes this thing equal to 0, and that would be bad. So right now, we're looking at a domain here such that the x has to be greater than 0, and it can't be either one of these things. Now, I guess if we say x is greater than 0, then negative 2 is already out. So we don't have to mention that twice probably. But if I were to say x is greater than 0, it seems like 2 is part of that. Positive 2 is something that's greater than 0, but that's something that we shouldn't be as well. So we're definitely going to have to mention that. I have to be greater than 0, but I can't be 2. And so we're looking at, if I were to write that in interval notation, I'm thinking it's something like this. Greater than 0, so we'll start from 0. Here, let's do it in a regular pen. Greater than 0, we'll start from 0. Can't be equal to it, so parentheses, start at 0, and we're good all the way until we hit the number 2. But that's bad, so we'll close it off and union it and say we're good anything after 2 all the way until infinity. That's what I'm looking at. Interval notation, I'm saying anything bigger than 0 except for the number 2. That's what looks good for, or whatever this is called. What's it called? For h of x over g of x. And then we have other issues that pop up when we're dealing with composition of these functions. And so let's look at those two things together. We'll do at least one of them real quick. So if we had to figure out the domain of h composed g of x, or h of g of x, that'll look like us plugging the g function into the h function. So it'll be h function with g function inside of it. And so that'll be a 1 over square root of, and it was x, but now we're plugging junk in there. So instead of just x, it'll be 1 over, the whole g function inside there. So that'll be x squared minus 4. That's the g function shot into the h function, just as it's stating here. G function inside of h function. See, you can clearly see. Anyway, it's what it says there. And so from here, guys, we've got similar issues to consider. I don't want the bottom to be 0. So if x squared minus 4 ends up being 0, that's bad. So we'll go ahead and by the same kind of factorization, right off the bat, we have the 2 and negative 2 once again are bad because negative 2 or positive 2 would make this thing equal 0. And if I have 0 in there, then that means this whole bottom is 0. And then that would be, square root of 0 is still 0, so it would be undefined. So bad. We want to make sure that 2 and negative 2 are not in the domain. Those are bad. So we'll keep our mind on those. 2 and negative 2 are bad. And then what else do we have to consider? Let's see. It's still a square root down here, so I don't want that to be negative. So then this x squared minus 4, the stuff that's inside the square root, I don't want that stuff to go negative, so it has to be greater than, so it has to be greater than or equal to 0. I don't want it to be equal to 0. That's how we got into this pickle, so I guess we're going to just say greater than 0. And so this would be a very similar process, but now we have to figure this idea about what if x squared minus 4 is greater than 0? We got to make sure that happens, and so we'll solve that out. If you were to do that, and we're looking for, you guys might remember when we were solving inequalities, we make it 0, then we pretend like we're looking for exactly 0, and then we got to test points that'll make this thing greater than 0 after all. We already know how that goes. It's x plus 2 and x minus 2. That's what will make this thing become 0. And so let's see here. We'll test our negative 2 and our positive 2 and then numbers around them. So if we were to look on the number line, here's negative 2, here's positive 2. First off, we know in the domain, those are bad. From way up here from before, we know that negative 2 and positive 2 are bad. So we're going to say these are open circles for sure. They're not part of the domain already. But then when we're testing points, we got to do our little test point thing. and we'll say, let's try something between -2 and +2. I'll try the number 1 again. I avoid doing 0 in these situations. Whatever. Anyway, you can do 0. I'll do 1, and I'll test a number over here, like 3, and I'll test a number over here, like -3. And then of all that, some of these, one of these pieces, or maybe one or two of these pieces in the number line will be good and keep our expression, our x squared minus 4 greater than 0. Because if it keeps it greater than 0, then we're still cool. But if it becomes less than 0, then it's not undefined. It's imaginary, It doesn't go well with real numbers. So we're just going to try some numbers here. We'll try -3, we'll try +1, and we will try +3, and then we'll find out what parts of this number line are indeed good news for us. So let's try that on another slide here real quick. Here was our -2 and our +2, and we're going to try -3. We're going to try +3. We're going to try like a 1 or a 0 or a -1 or something in between there. So let's try all three of those. And we're trying them in x squared minus 4. Keeping that in mind, let's see. If we have -3, let's try -3 first. -3 squared minus 4 would be -3 to the 2 minus 4. That's 9. Negative squared is positive, so 9 minus 4 is +5, and that's good for us. That's 5, which is greater than 0. So if I plug in numbers that are on this side of my number line, it seems like we're getting numbers that we're getting outputs for our expression that actually are greater than 0, and it'll keep us from going imaginary. And we circle the 2's because we don't include those. So it looks like this part of the number line works, which means, to me, probably that means that the middle part won't. So let's try that to make sure. If I plugged in a 1, that would be 1 squared minus 4. 1 squared minus 4 is 1 take away 4, so that's -3, and that is not greater than 0. That's bad. So not going to use this part. That's no good. And then pretend like I plugged in something over here, and I'm betting that's going to work, and then just try it, whatever. It would be the same as the last one. 3 squared minus 4 is 5, so it's greater than 0. Anyway, so that one does work. And then this is essentially the picture of our domain as we know it. It's not including the 2's because we knew those were bad news in the first place. And then it's everything on the infinity left, infinity right. And so we'll just union that up. I guess if we were to say that, we would say it's anything from -infinity out to -2. Don't include it though. There's no box there. It's parentheses unioned with regular 2 all the way out to +infinity. And that's kind of what I'm thinking on that one.